So we're going to start with rectangular brackets are for sets that have a greater than or equal to sign or less than or equal to sign.
Professor, we can't hear you.
Better?
Yes.
Okay, good. Thank you. This is for something like x strictly less than 3.
Sorry, professors. I was trying to figure out why the volume wasn't working. Could you repeat the beginning of the definition of interval notation again?
We'll read through it. So the rectangular brackets are when you have included endpoints. And it means less than or equal to or greater than or equal to. And then strict inequalities are parentheses. Like x is strictly less than 3 and cannot equal 3.
You said it means less than or equal to or greater than and equal to?
Yeah.
And then what was the part after the brackets again? Are when you, interval notation, strict brackets are when you, and then I lost it after that.
Okay, actually, let's just go back. Let's go. Sorry, I didn't have a sound.
Sorry about that. Thank you, though.
That's good. That's what I'm here for. Rectangular brackets. Let's do this. So if you have this one to be, well, let's see. That's less than or equal to because it doesn't really, it depends on maybe how the set's written, but when you do it we'll do examples. When you do the interval notation, it'll have rectangular brackets. And let's see, I'm just going to put this down. Okay, so this would be like greater than and then equal to. Like part of an equal sign. And then less than or equal to some number. I'm going to put an example right here. So we'll have this set. It equals the set of values x such that 2 is less than or equal to x and x is less than or equal to 6. Let's do one more. Let's go from -1 to 4. Okay, this is the set of x values such that -1 is less than or equal to x. So x can equal -1, and it also could equal 4 with the square bracket. Okay, strict inequalities, like just less than, look like this. Okay, and just greater than symbol is that sign, so greater than. Or like, yeah, something like, so values that make the statement true, like 4 is greater than 3, 10 is greater than 3, but you can't equal 3, and x cannot be any number less than 3.
Are those the ones with the open circles? Right,
Yeah.
the strict inequalities. Okay.
Yeah, and I was just about to do that part. And then I'll talk about infinity. So open circles. Strict inequalities. And this will be when you do your graph for graphing strict inequalities. I don't need a circle. It's okay. Okay, and use a closed circle for the less than or equal to sign, greater than or equal to sign. Oh, wait, for graphing, something like that. Okay, one more part. Oh, I'm gonna check on the chat really quick. Reminder about your homework. We've got the volume up and go. Let's do note. Positive infinity will never be included in the set. You can't have the number infinity in your set, so it's going to have parentheses on it. Also, you're not going to have the number negative infinity in your set, or x will not equal negative infinity, so it has parentheses. Go. Lots of examples. So each of these examples, we will, I'll give you the set, and then we'll draw a graph, and we'll change that set to interval notation. For this first one, I will put like what the instructions would be if you did homework, but after that, we're just gonna start working on things. So write the set interval notation and we're gonna draw a graph. Okay. First set of x such that -2 is less than or equal to x less than or equal to 1. So your graph, you're just x values, so just a number line for that variable. You don't need a y, there's no y going on, just x. X is between -2 and 1. Put some units. 0, 2. And you can include -2. What was the question? Sorry, I didn't comment. So I'm just going to read this again to be clear. So this is the set of x values such that -2 is less than or equal to x. X is less than or equal to 1. So we're going to include -2 and 1. Get all the x values that make this statement true. One of those values is 0. 0 is greater than or equal to -2. 0 is less than or equal to 1. This is one of your solutions, and actually everything between these numbers is a solution. Oh, interval notation. So include -2 with a square bracket. Also include 1 with a square bracket. And I'm just going to put a note down that you always have your small numbers on the left, the smaller number on the left, and the larger number on the right. So you read from the small number to the larger number. Yeah. Let's take the set of x such that 10 is strictly less than x, and x is less than or equal to 20. Start the graph. Okay, these are values of x on a number line. I'm gonna mark, I like to mark 0. Let's just do 0, 5, 10, 15. Okay, mark some units, and we're not going to include 10 with that strict inequality, so you open circle right there. And then go up to 20 and include 20. All the numbers in between. Okay, your set goes from 10 to 20, not including 10. You do include 20. And then that's your set written in interval notation. And the small, oh, read this. Yeah, I see the glare too. Okay. The smaller number goes on the left side of the set, like this. 10 is on the left side, 20 on the right side. Cool. We're at the set of x values.
This is another example, Professor.
Yeah, we're going to start
Okay.
new problem. Okay, write the following set in interval notation. Your set of x values such that 6 is strictly less than x, strictly less than 8. Okay, I think a graph helps, so we're still going to draw a graph over here. Let's put some units down. 0, 2, 6. Oh, we're up here. We're not going to include 6. Also not including 8. But all the values in between. So you go from 6 to 8. Parentheses. I think that's the answer. I like to put a little circle around my answers, but start a new one. So actually, any questions, anybody? Or comments if it should slow down or anything like that? Okay, well, just stop me if you have a question. Okay, this time x are values such that x is less than 3. I'll do the graph and then go back and do interval notation. We need a placeholder for 3.
Can you read the set again really quick, Professor? One more time, the set.
Yeah. The set x such that x is strictly less than 3. And close the set.
Perfect, thank you.
So we have a circle here. It's open. And we're looking for values of x that make this true. So 0 is less than 3. Negative numbers are obviously, hopefully it's obvious that negative numbers are less than 3. So this is a positive number. So you're going this way. It's negative infinity. But if you need to do some testing, that's fine. You can do some test values for x and just see if which side's true and which side's false. We'll try that next problem. From all the way over here, negative infinity, up to 3, and don't include 3. So this is the set that goes from negative infinity up to 3, not including 3. That's the graph.
Wait, when do you use the brackets and when do you use parentheses again?
Yeah, parentheses is when there's just less than sign. And if I had a equal to right here, then we would fill this in, and this would be square. So you use parentheses. Or these symbols. Then brackets. We'll put square brackets. Cool. I think we're doing some more examples. So this time we will write the set in interval notation. And we'll do the graph too. So we have the set of x such that x is greater than 0. We'll put greater than or equal to, 0. I'm going to start with the graph. We have x values here. We need 0 on our graph. This line here means include 0, so we'll put a solid circle. And x values that are greater than 0. Let's do some testing. So we're just going to see if you put in -2, will the statement be true? And if it's true, then it is part of the set. If it's false, then those values aren't part of your set. I'm going to make this bigger. -2. So negative number greater than or equal to 0 would be false. Then x cannot be -2. Could x be 5? And we'll test it. Put 5 into the inequality. So is 5, we had greater than or equal to 0. So if it's true, then x can be equal to 5. And 5's over here. That's one of the values in your set. Same for, also I'm going to put -2. So we had a false, okay, with 0 is kind of like the divider. And on this side we tested -2 and got false. This side we tested 5 and it was true. We're going to select that side. So if you're ever unsure about how you've drawn your graph, you can do some testing and just think about what x could be. Let's write the interval notation. We go from 0, including 0, to positive infinity. So you put a square bracket on the included endpoint. Positive infinity always has parentheses. Next one, so starting a new example. Our set looks like the set of x such that x is less than 4. Let's do the graph first. So we need a placeholder for 4 on a number line. We don't include 4. There's no equal sign, so open circle on 4. And I'm going to do another testing part. We're going to pick some number on this side of 4, like 1. And we'll pick a number on the other side of 4, we'll choose 5. And see which side's the true side, which side our set is on. Okay, here, putting in 1 for x is 1 less than 4. Yep, 1's less than 4. So that's true. We're going to have this in our set, and actually all values on that side. We'll make that statement true. But if you put in 5 for x, 5 less than 4, let's clean this. else. Okay, so this is not a solution, and other values that are greater than 4 are not solutions. They are not in your set. This side is the solution set. That goes from negative infinity up to 4. Don't include 4. Negative infinity has parentheses. Go up to 4. And with the strict inequalities, you use a parentheses. And that's the set. Whoa. Okay, so it's going to get a little more interesting in just a second. We'll do another example. Lots of practice. So write the set in interval notation. And draw a graph. Okay, so for this problem, we'll put the set up here. So it's just like we introduce the problem and we'll work it out over here. Okay, it's x values, a set of x such that x is greater than 5. Okay. Get a graph ready for your x values. Add 5 somewhere on that graph. There's a circle on 5. You're not going to include 5. X is strictly greater than 5. And find the x values that make the statement true. So 6 is greater than 5. 10 is greater than 5. So we're going to go larger and larger numbers will make the statement true. Past 5. Okay. So we have a set that starts at 5, not including 5. So parenthesis around it. It goes to positive infinity. In something sort of different. So check on time. Okay, we're going to write the set in interval notation and draw a graph. this set. It's the set of x such that x is less than 1 or x is greater than 2. Close your set. So when you have or, there will be 2 parts to your graph. Important places to mark are 1 and 2.
Is it a strictly less than 1?
Yeah, strictly less than 1 or strictly greater than 2. Thank you. Open circle on 1. And find values of x less than 1. Go to negative infinity for that part. This side, x is strictly greater than 2, so open circle on 2, go past 2. Okay, to put these pieces together, you use the union symbol, so it's in this set or it's in that set. Starting with the small side. Smallest number or smallest value is negative infinity. To 1. Don't include 1. Union the set. The set that starts at 2, not including 2, goes to positive infinity. That's very small. Okay, so same kind of idea, but let's just erase the board. Another example like this, though, where you have an or in the problem. Let's just change it up a little. Draw a graph for the following set. And write the set in interval notation. Okay, this is the set of x values. Set of x such that x is less than or equal to 8. Or x is greater than or equal to 12. Okay, so we need a place for 8 and a place for 12 on the number line. Let's go like Let's just start somewhere, I think. Just put 8. We're going to include 8, so close circle on 8. And all values less than 8. So x is less than or equal to 8 means you're going to negative infinity. Or x is greater than or equal to 12. So a closed circle on 12. And x values that are greater than or equal to 12 are this way on the right. So you start with the smallest value, negative infinity is, well, first, interval notation. Would be to start at negative infinity, go to 8, include 8 with a square bracket. Union your set with a set that starts at 12 and includes 12. So first we did the graph, and then we got the interval notation, and we're done. Okay, I think we should do one more of these, but then I'd like to go on to some other topic. So. Okay. Here's set. Starts. It's got x values such that x is less than or equal to negative 5. Or x is greater than 1, negative 1, or x is strictly greater than negative 1. All right, our graph is a number line for some value x, some variable x. We need negative 5 and negative 1. Oof. Cool. We're going to include negative 5, so close circle there, and then get all the x values that are less than or equal to negative 5. So starting here, and this way. Then this part or x is greater than -1. So open circle on -1 and values that are greater than -1 are like 0 is greater than -1. Any positive number is greater than -1. So we're going to go this way towards positive infinity. And that's it for the graph. Now interval notation is, let's see. It's going to start on the left, -infinity up to 5, include 5 with a square bracket. Union it with the set, so or the set that's going from -1 to positive infinity, but doesn't include -1. So we need a parenthesis there. Go over to positive. And this is union.
It'd be a -5, Professor.
Yeah, thank you, thank you. Yay, I think that's a good practice for that topic. Let's do something different. Any questions though? I'm going to leave this for a minute. So we've been talking about variables, and we have two ways to draw a graph for the data that you get from your variable. So there's bar graphs and histograms. Okay. The first one, we use bar graphs to graph qualitative data. Quality. Okay, these kind of graphs, you have these bars and the bars don't touch. Your categories are separate from each other. So the bars in your bar graph do not touch. Use a histogram. To graph quantitative data. And in those graphs, the bars do touch. So quantitative quantity. Some kind of variable. And the bars. Okay, so I've got a bunch of these. We'll see how many we can get through. But make sure I don't lose track of time. 10, 15. Okay. So we're going to start a problem. And it says to construct a bar graph. construct a bar graph for the following data, and we're going to list that in a table.
Professor, is that just something like for us to know for which one has qualitative and which one's quantitative, like, or will like could we be tested saying like, hey, if you're classifying eye color, what would that be versus, and then we would say, you know, that's a bar graph versus how many people with green eyes, that would be a histogram. Would we be tested on that, or just to know?
I probably wouldn't test like that. And I would probably be clear, like, make a bar graph, you know, just tell you what you need to do.
Okay, cool.
We'll see how that goes. Yeah, I guess this is it's the next topic in this section of the book, but I'll have to figure out how I would ask questions about these now that we're doing homework online. But I'll figure it out. We'll find a way. Okay, so you're given a table. And then the frequency. And it's going to have red, orange, yellow, green, blue, purple. R for red. O is orange. Let's make some space. Okay. Y for yellow. Red, orange, yellow, green. Blue. I've got 2 for red, 5 for orange, 6, 1, 3. We're gonna need some space, so if you need a sec to write this down, we'll wait and then erase everything. Okay, so I've got a copy of this on my notes. I'm just gonna erase. Okay, so it's up to you if you like to put the categories this way or the categories that way. I'm gonna put them on the bottom. Oh, and also thank you for the person who put the table in the note in the chat. Thank you very much. And that helps me too. So for red, orange, yellow, on here. Green, There's no overlap in these categories, so each bar will be separate from the other one. And we're going to need to go up to a height of at least 6. So let's do like 1, 2, 6, 1, 7. So a bar that goes up to 2 and then back down around red. I'm going to shade it. Okay. Orange goes to a height of 5. So go around orange, bars don't touch, up to 5 and over. Okay, yellow has height 6, so all the way up to 6. Again, bars don't touch. Okay, green, it's just height 1. Little guy right here. Blue goes up to a height of 3. So 3, yeah, as best as you can sketch. And then last one, purple, height 4. That's your graph. So what I was thinking was to try to give you a graph and have you read from it instead of having you draw one, since we're not in person. Let's try one more and then we'll get back to this next time. Okay, so last example for today is to construct a bar graph for the following frequency distribution. Okay, that's good enough. All right, categories are 2, 4, 6, 8, 10. And I give you frequencies. Two occurred 15 times. 4 has a frequency of 20. 6 has a frequency of 10. 8's frequency is also 10. Last one there. Okay. I think we can make it fit right here. So let's put this bar graph. Bar graph. Okay. Category. I like to put the categories on this side here. So we had 2, 4, 6, 8, 10. And then let's see, the largest frequency is 20. So we need to have this go up to 20 at least. So let's do 20, half is 10, half 10 is 5. So it's 15. Okay, and our bar graph, bars don't touch. Around 2, we have a height of 15. Okay, around 4, height is 20. Oh, what's this? Check this label. Okay, around 6, we go up to a height of 10. And you're at 8, also height of 10. Last one, around 10, go up 5. And then just to make it clear that this was our place for category, or yeah, categories. And this was the frequency. That's good for today. So if I know you to put this on your next homework, but we won't have another homework assignment till next week. All right, thank you everybody. Have a good day. Stop recording.